Hi, let's see one of the important application, which is traffic flow. And these traffic networks can be described by directed networks. And whatever you see the intersection here, this corresponds to the nodes of the network. You can see the nodes are A, B, C, and D. So these intersection that we call it as the nodes of the network, and the roads are correspond to the directed edges or branch. So you can see the roads, that is x1, x2, x3 and x4. So we have to start the problem with an assumption that the total traffic entering the network is equal to the total traffic leaving the network. So whatever the traffic that enters, it has to leave and it can't stay in between. So with these assumptions only, we can start the problem. Now let us form the equation. Now you see at node A, that is at the point A, what is the flow in? The flow in that comes towards A is, see, 125 and 350. These two are coming towards A. So this is nothing but 125 plus 350. What is the flow that goes out of the network is, that is x4 and x2 that goes out of the network. So, and how can we decide whether it's flow in or not? Now if you see this line, 350 line, this is coming towards this point. So if you see this line, 125 goes inside the node A and this x1 is going outside. So your flow out for the same node A is x1 is also going out and x4 is also going away from A. So x1 and x4, so I'll write it as x1 plus x4. Similarly, at each point, say at node B, okay, what is the flow in at the point B? So if you see, 400 is going out. So I will write this 400 at this place, flow out. Okay, 400 is going out. This 225 is also going out. So I'll write 400 plus 225 at the point B. And what is coming towards B means then x1 and x2 are coming towards B. This x1 is also coming towards B. x2 is also coming towards B. So your flow in is x1 plus x2 at the node B. Similarly at C, can we see what is the flow in and flow out? At the point C, and these arrows, you can see here, the arrows are going here. This arrow is here, right? So this 800 and the other value, that is 250, you can see the arrow here. So it means 800 and 250 is coming towards C. 800 plus 250. You can see one arrow here. With this arrow we are guessing. Okay. And what is going away from C? This x3 and x2 is going away from C. So x2 plus x3 or x3 plus x2, you can write in any way. So at the point D, what is flow in? This point. So what is coming towards D? This x4 is also coming towards D. This x3 is also coming towards D. x4 plus x3. And what is going away? After D, we have 300 and 600. So your flow out is 300 and 600. Now we are going to write this as an equation where you're just going to write this as flow in is equal to the flow out. By using that assumption, we will get the equations. What are those equations? What is the first equation at A? x1 plus x4 is equal to 125 plus 350, which is nothing but 475. Okay, so this is your first equation, that is flow in is equal to flow out. We'll write all the x values on the left hand side, y values on the right hand side. So here this at B is x1 plus x2. And this value is nothing but 400 plus 225. And if you simplify, it is 625. We got the second equation. Now at C we are going to see, that is always we'll write x1 and x2 on this left hand side I said, x2 plus x3 on this side, and 800 plus 250 is on this side, which is nothing but 1050. And your last equation at the point D, x4 plus x3 I'll write here. On the right hand side, 300 plus 600, which is nothing but 900. So you got 4 equations. So let me rewrite these equations, and we are going to just enter it in an augmented matrix. Already we know how to write an augmented matrix because we have done, yeah, Gauss elimination and all those things. Your first equation is x1 plus x4 is equal to 475, which means x1 is coefficient is 1, x2 and x3 is not there. Your second equation is x1 plus x2 is equal to 625, and your third equation is x2 plus x3 is equal to 1050, and your last equation is x4 plus x3 is equal to 900. When we write it in augmented matrix form, the other coefficients will become 0. So the augmented matrix is given by, so we will write A colon B is nothing but, here x1 is there, coefficient is 1. There is no x2, there is no x3. So x2 and x3 will become 0. And there is one x4, 1 colon 475. Similarly, here x1 and x2 coefficient is 1, 1. No x3, no x4, 625. And the next line, x1 is not there, so 0. x2 coefficient is 1, x3 coefficient is 1. There is no x4, 1050. And last, there is no x1, x2, and x3 is 1. Here we have, and x4 coefficient is 1, 900. And this is your augmented matrix. And already you have solved Gauss elimination, Gauss Jordan, all those things. You have to simplify this by using a row echelon form, and we are going to find out the unknown values x1, x2, x3, and x4. Now your augmented matrix, we have to reduce it. What is our first target? This one I should make it 0. And then see all the non-zero terms which is in the lower triangular matrix, first you try to make it 0. And this one also you try to make it 0. So since already these two terms are 0, first this should be your target. So 1 0 0 1 475, and I will write R2 goes to R2 minus R1. So this term will become 0. And then 1 minus 0, 1. 0 minus 0, 0. 0 minus 1, minus 1. And then we have 625 minus 475. We can simplify that and write it, which is nothing but 150. And now if you see, these two are already 0. Better we will write this and do the transaction in the next step. So now, clearly what is our target? I want to make this as 0. This is my target. So what I will write, R3 goes to R3 minus R2. Because if I take any other one, this will not become 0. So I have to use these two to make this fellow 0. Correct? So your A colon B, the augmented matrix will be equivalent to 1 0 0 1 475, and then yeah, I have written the other values. Your R2, it is the same. That is because we didn't do any change in R2. So 0 1 0 minus 1, and the 625 minus 475 150. R2 is the same. We are changing only R3. R3 goes to R3 minus R2. So 0 minus 0, 0. 1 minus 1, 0. 1 minus 0, 1. 0 minus of minus 1 will become 0 plus 1, that is 1. And 1050 minus the previous value is 150. So this will become 900, this value. Now, the row 4 I have written as it is. If you see this, actually this should be my target. This I have to make it 0. So if I have to make it 0, what I should do? I have to write R4 goes to R4 minus R3. If I write R4 goes to R4 minus R3, your augmented matrix, the last two rows will become exactly the same, and if you subtract it, it will become the last row, it will become 0, because 0 minus 0, 0, 0 minus 0, 0, 1 minus 1, 0, again 1 minus 1, 0, 900 minus 900, 0. If you notice that the last row exactly became 0, and our target was to make it as an upper triangular matrix, and this is how we got. Now if you see, we have to rewrite this again in the equation form, because first in the equation form to your row echelon form you have reduced. Now after the reduced row echelon form, again you have to write it in equation, same as your Gauss elimination, all those things. So this is x1, there is no x2, there is no x3, and this is x4. So x1 plus x4 is equal to 475. And there is no x1, x2 plus this is also x3, knows x3, and this is minus 1. So please be careful. Minus x4 is equal to 150. No x1, no x2, x3 and x4 are there. x3 plus x4 is equal to 900. And finally we have the last equation completely 0. If you remember that how to check consistency and whether the solution exists or not, here the number of unknowns is 4 and your equations are 3. So you can choose one as arbitrary, and here we will see the range for this, each x1, x2 and x3. I have written all these things. From the first equation, you can write x1 as 475 minus x4. And we know that all these values should be greater than or equal to 0. So, if I have to subtract this and I should get a positive value for x1, this x4 should be less than or equal to 475, because I want a positive value. Similarly, I am taking the second equation. Here it's negative, so 150 plus x4. x4 can be any positive value, so that x2 also can be any positive value. I couldn't see any restriction here. Now again see the last one. x3 is 900 minus x4. So again I want x3 should be greater than or equal to 0. So this x4 value should be in such a way that it should be less than 900, so that it should be a positive value. Now I am giving two conditions. I want an x4 which is less than 475, also which is less than 900, means obviously I will go for the smallest value. So I can choose the range for x4 as 0, less than or equal to x4, less than or equal to the smallest value, that is 475. And here x4 is any arbitrary value which is a positive value. That is what we mean here. And the next condition is the second question. So we are done with subdivision 1. So when x4 is 0, automatically we'll substitute this x4 as 0 in the above equations, and we will get x1, x2 and x3. Now I have written all the equations for our convenience. So when x4 becomes 0, x1 plus 0 is 475, so x1 is 475. Similarly, x2 minus 0 is 150, so x2 is 150. And last equation, x3 plus 0 is equal to 900, x3 is equal to 900. And your last question is, when x4 is equal to 100, what could be the values? Because x4 can take any positive value. So here they have given a particular value. When the road is closed, automatically there is no flow in the x4. So when the road is closed, they can say, or when x4 is 0, they can say. When they mention the road is closed, they mention particularly that road x4 is closed, so that you can take this condition. Similarly, substitute x4 as 100, 475 minus 100, you will get x1 as 375. x2 is also 150 plus 100, so 250. And hence, x3 is also 900 minus 100, 800. Thank you.